Hello, everyone. My name is Malcolm Guzman, and today we're going to talk about Herceptin. So, how does Herceptin work? Herceptin's mechanism of action has to do with the fact that it's a monoclonal antibody, more specifically, a humanized monoclonal antibody. Now, what does that mean? Well, turns out mice have an antibody that is able to bind. Let's say a mouse has an antibody that's able to bind to a specific antigen that we're trying to target. If we were to take those antibodies out of a mouse and inject them into a human, our bodies would immediately target that antibody and inactivate it, so then it wouldn't do what it was supposed to do, in this case, mess with cancer cells. So what is done to create a humanized monoclonal antibody is we take the antigen binding site of a mouse monoclonal antibody, and then we combine it with a human antibody, and so we attach just the part that binds to the antigen that we want, combined with the rest of the body of a human antibody, and that way it prevents our body from rejecting and targeting this antibody for attack. This specific antibody binds to human epidermal growth factor 2, or HER2 protein, and this protein is a receptor for cell proliferation signals. And whenever it binds, it is able to inhibit the activity of that receptor. And that's how Herceptin is able to prevent cell growth. Now, exactly how that happens has to do with the fact that HER2 is amplified, 25% amplified in cancer cells, which means that there's 25% more HER2 protein in the membrane of cells than there would be in a healthy cell. As a result, the cell is able to pick up more growth signals, and that leads to uncontrolled cell growth and cell proliferation. Now, what happens when the Herceptin antibody binds to the HER2 receptor is that it inhibits it from receiving the cell signal when it needs to proliferate, causing a slowdown or even stopping cell growth and proliferation in general. In addition, HER2 proteins that are bound by these Herceptin antibodies are more likely to become endocytosed by the cell, leading to downregulation and restoring a sort of normal level of Herceptin in tumor cells, again, slowing or even stopping cell growth. And in addition, the fact that cell signaling is blocked in these cells makes it more likely that the cell will undergo apoptosis, once again getting rid of cancer cells and preventing the growth of tumors. Side effects included in the taking of this drug include headache, diarrhea, nausea, chills, fever, heart problems, infection, insomnia, cough, and rash. And I believe this has to do with the fact that Herceptin inhibits cell growth, since the HER2 protein is present even in healthy cells. So what happens is that the inhibition of cell growth, as well as the increased levels of apoptosis of cells that have Herceptin bound to their receptors, can cause deterioration over time, and it can cause heart problems by causing damage to the cells and increasing infection risk. Now, with that in mind, with how these proteins, antibodies fight infection, fight tumor cells, my question is, side effects aside, as we discussed before, from taking this drug, does this mean that these kinds of antibodies, monoclonal antibodies that target the growth of tumors that mediated by growth receptors, like growth signal receptors, does that mean that these types of antibodies could be used to prevent tumors from developing in the first place, sort of by offsetting the activity of this amplified receptor protein and preventing the tumor from developing at all? So basically, just if you were to take this antibody at the early stages of cancer, would that prevent cell growth at all? Or if you're at a high risk of developing certain cancers, could this type of treatment help you prevent you from developing tumors in the first place? So that's going to be it for me, and that's all about Herceptin. Thank you very much for watching.